So far, our logical language has included the concepts of if and not. Now we're going to introduce the concept of and in this video I'm just going to talk about some of the simple pieces of that in the logical language. So if you remember Logic blocked Joe, he's watching television and the announcer says what the winning lottery number tickets are, and Joe thinks, if I have those numbers, then I have just won myself $1 million. And he looks down at his ticket and he says, I have those numbers. And then nothing happens. He draws no conclusion. That's because Joe is incapable of recognizing modus ponens. Obvious seems trivial, but it's actually important. It's both obvious and important. And we're going to see more obvious and important inferences in this little unit. So Joe shows up at the airport, and he walks up to the attendant at the desk, and he asks her, says, "The bathrooms in this corridor are locked. Where's the closest men's bathroom?" And the attendant says, "Well, if the bathrooms in this corridor are locked, then the closest women's bathroom is in corridor T, and the closest men's bathroom is in corridor U." And Joe is confused, and he understands what's been said. Maybe he understands, but he says, "But where is the men's bathroom?" And you say to Joe, "Well, the closest women's bathroom is in corridor T, and the closest men's bathroom is in corridor U." And so you do the modus ponens inference for Joe, which we know he can't do, or which he apparently is unable to do in this situation. And Joe says to you, "Yes, but where's the closest men's bathroom?" And you say, "The closest men's bathroom is in corridor U." And Joe says, "Oh, great, thank you." And so here we have another example of Joe's logic block. We have the sentence, "The closest women's bathroom is in corridor T, and the closest men's bathroom is in corridor U." And the inference that you draw, that Joe is unable to draw, is the closest men's bathroom is in corridor U. This is about as obvious a logical inference as they get, yet nonetheless, given Joe's incapacities, he's not able to draw it. And this is a good inference. It's valid. No matter what, if the premise is true, then the conclusion is also true. If P into Q, or if any AND statement is true, then both of the parts of it are true. And that's just what this inference does. We want to capture this inference in our logical language, and that's what we're going to do in this unit. And we're also going to capture some other AND inferences in this unit. So we're going to call AND conjunction. That's another word from Latin. And this is the conjunction symbol. It just means AND. So when we form a sentence with it, we will call the whole sentence a conjunction. So P into Q is the conjunction of P and Q. And we call P a conjunct, and we call Q a conjunct. So we have the conjunction symbol, just like we have the conditional symbol. We have sentences that we form with the conjunction symbol. It just goes between two sentences and says they're both true. And we call that whole new sentence a conjunction. And the two pieces, we say each one is a conjunct. So that's the introduction to conjunction. In the next several videos, I will be getting into conjunction inference rules and also symbolization with conjunction and how conjunction interacts with conditionals. So I will see you there.